Good morning, everyone. Good afternoon, depending on where you are on the planet. Thanks for joining us on today's webinar. Today we're going to cover alarm handling with the graphical alarm handler. Some of you will be familiar with this. It's maybe 22 minutes long, my presentation, including a live demo. So if you do have any questions throughout, as always, please use your questions option in the control panel in the webinar window there, and we'll do a live session directly after the presentation. Okay, let's get going.
Hi, in today's tutorial we will be covering alarm handling. We will be discussing the following topics. We will talk about alarm handling and its functionality with a live demonstration. Then we will finish with a Q&A session. Okay. Let's take a look at alarm handling. What is alarm handling? It is a feature which can be configured by system designers to enunciate and manage abnormal machine conditions, primarily alarms. It provides a means for operators to be aware of and manage alarm conditions as they occur. And it provides a means to maintain a historic record of alarm conditions as well. It's a popular feature with HMI type products. Our all-in-one controllers combine the functionality of a PLC and an HMI with built-in I/O and networking. In our Seascape software, alarm handling is configured in the graphics editor. We support up to 1024 alarms and up to 16 groups. Each alarm has a trigger bit. When the trigger bit is on, the alarm is active, and when it's off, the alarm is normal. An alarm has 3 states to deal with alarm conditions. When the trigger bit is active and not acknowledged, the state is said to be in alarm, abbreviated to ALM. When the trigger bit is active and has been acknowledged, then the state is said to be acknowledged, abbreviated to ACK. When the trigger bit is normal, we call that return to normal, abbreviated to RTN. An operator can acknowledge and clear alarms as needed, as long as the system designer allows them to. There are 2 types of alarm information that can be displayed to the operator. There's alarm summary information, which is the current status of the alarms, and there's alarm history, which is a historical record of the alarm's previous states. Alarm information can be displayed in one of 2 graphical forms. You have an alarm window, which effectively is a window into the alarm conditions, either current or historical. The number of alarms displayed can be changed by resizing the window. You also have a Configure Alarm button, which shows the status of alarms in general. If you click the button, the alarm object takes full control of the screen and additional details are displayed. Now, let's do a demonstration to show you how alarm handling is configured and how it operates in runtime. Let's have a look at how we configure alarms in Seascape. To configure alarms, we need to start from the graphics editor. So I'm calling up the graphics editor here. As you can see, we have an XL4 controller that I'm going to set up for alarm handling. From the graphics editor, I'm going to go to Config and select Alarm. This is where you configure alarms to set up alarm handling. The first thing I'm going to do is I'm going to select how many alarms I want to support. In this example, I'm going to support 8 alarms. Next, I will assign a series of bits. Each bit represents 1 alarm. In this case, I'm using the traditional register base ladder, and I'm going to use internal non-retentive bits for my alarm status. You have the option to use retentive bits or registers. In this case, I'm going to go ahead and assign T1025. Notice I used an address that is on a word boundary. Next, I have the option of assigning 2 additional bits for remotely acknowledging and remotely clearing. So generally, you acknowledge and clear alarms from the screen, so that's typically an operator function. However, if you have a need to remotely acknowledge or remotely clear an alarm, you can assign bits here for that purpose. Currently, these are strictly for acknowledging all the alarms or clearing all the alarms. They're not individual bits or for individual alarms. But they're also optional, so I'm not going to assign those here. Next, because we selected 8 alarms, I've got 8 blank default alarms listed here, and these will be tied starting at T1025. So the bit that will cause alarm number 1 to turn on is T1025. To turn alarm number 2 on, that is T1026, etc. And I'll show in ladder how these can be tied to machine conditions in a little while. Next, instead of having these default alarm strings, I'm going to type in what these alarms mean in my particular case. So I will double click here on undefined alarm 1 and make that under temp zone 1. Alarm number 2 will be over temp zone 1. Now, you may notice that it could take quite a while to type all of these alarms in, so you do have the option of copying and pasting these to and from Excel. That can be much faster than what I'm currently doing, but I'm only doing a few alarms, so I'm going to stick with typing them in individually. I'm making this one PSI fault zone 1. Okay, I'm going to type in a few more alarms here. Let's call this one motor overload. And finally, let's make this one e-stop tripped. Okay, now I will talk about the ability to group alarms. So as you can see here, there's a column showing group 1. You have the ability to create up to 16 groups of alarms. So if you have a machine with different zones or different functions, and you would like to group your alarms by zone or by function, you have the ability to do that. So as you add alarms, whether it's directly here or with Excel using the copy and paste function, you have the ability to assign different groups to different alarms. In this case, I'm just going to leave everything in a single group. Now, there's a variety of other things we can configure here, but I'm going to come back to that after I've gone through how to utilize alarms on the screen. So I'm just going to press OK here. Now, when it comes to displaying alarm information, we utilize what's called the alarm object. The alarm object is accessed here. It is a small icon with an alarm clock. I'm going to select that and then click and drag. By default, when you use the alarm, you can place it on the screen and it creates an alarm window. An alarm window is a device or an object that shows you some lines of information about alarms. That can be what's currently happening with your alarms, an alarm summary, or it could be what's been happening with all of your alarms, an alarm history. Let's double click this object and configure it. First, we are going to configure whether this device shows a summary of current alarms or shows a history of alarm activity. In our case, I'm going to make this a summary. We can configure whether we want this alarm object to be a window as it is by default, or if we just want this to be a button. In other words, we only want to show a quick small button on the screen that by its color will indicate whether there are any alarms or not. So let's go ahead and do that before we configure anything else. Hit OK. Now you can see our alarm window has turned into a button. I'm going to configure it in something of a more reasonable size. So on a screen with lots of information on it, this would allow the operator to see at a glance what's happening with their alarms by the color of the object. Now, what controls the color? If we go back into our alarm configuration, we can see under the summary button colors that when we have no alarms there, it's going to be green. When alarms have not been acknowledged, it's going to be red. When there's current alarms, but they've all been acknowledged, that button is going to be yellow. During runtime, you can press this button and see all the details. I will show you that later in the runtime portion of this demo. So we've configured what we would call an alarm button, and in this case, we've tied that to what's currently happening with our alarms by defining it as a summary. There's a few other options that we can configure. We talked about groups and managers. You can configure which of the 16 groups are included when you're looking at the details for this particular button. So you can configure how the information is presented to the operator. You can edit font size, date, and time formats. You can also display the alarm state if you like. You have many options to customize the displayable information to the operator. Well, let's wrap that up as an alarm button. Let's go back and select the alarm object again here with this icon. Let's go ahead and leave this object as the default alarm window, but this time I will configure it for alarm history. So this object will show us the history of what's been happening with alarms, and the specifics of what states are actually recorded under history. Let's go back to our alarm config and see where those can be set. So up here in the upper right hand corner, this is where you have the ability to define for a history object what particular events you want recorded. By default, we record them all. You also have the ability to configure a removable media log. So what is this? Well, this is the ability to record what's happening with alarms to a file on your memory card. So I'm going to enable that here. You can configure the frequency of when new files are created. The default is daily. If you're looking for something weekly, monthly, yearly, etc., you have those capabilities as well. You can then define an alarm log path. We want this to go into a subdirectory called alarms. Then you can select your time and date format. And then you have a status register that you can define that will allow you to monitor the process to make sure everything is working properly. Okay, so that was the alarm log that you can make for removable media. Next, let's take a look at how these alarms are triggered. If we go back to the configuration, we've assigned a series of bits, in this case 8 consecutive bits starting at T1025 that will enunciate alarms. But how do those alarms get tripped? That's where we depend on external events that may be documented in ladder. Let's go back into the ladder and take a look at how that might work. So I have created some simple ladder logic that effectively is defining what causes each of the alarm bits to turn on. So for my low temperature alarm, I'm checking to see if the temperature that I'm monitoring by the OCS is below the threshold for an alarm. If so, then it will trigger the bit. For a high alarm, similar, but a greater than instruction is used instead of a less than instruction in the logic. If my pressure is out of range, I'm using a limit instruction, which basically says if the current pressure is outside of a certain range of limits, and that has occurred for 5 seconds, then I'm going to turn on the pressure alarm. In the case of a motor overload, it's strictly a matter of a bit turning on or off that's directly wired into an input. And then lastly, any stop trip is the same scenario as the motor overload. Okay, so now that we've shown you how to configure alarms, let's take a look at how they work in runtime. Here's an XL4 running a demo program very similar to what we've just configured. I'm looking at an alarm status screen, which contains an alarm button. Now, an alarm button indicates the current status of alarm in terms of its color. So it's currently green, which indicates no alarms. At a glance, it can show me if I have any current alarms, if they've been acknowledged, or if everything is normal. You can click on the button for more details. In this example, I also have an alarm history screen, which contains a window that shows me details about the alarms. In this case, details about the history of what's happened with the alarms. Okay, let's go back to the status screen, and let's simulate an alarm condition. Let's say we have an over temperature condition occur. The alarm button has now changed from green to red, so that indicates to the operator that they've got a new alarm. As the operator, when I press that button, I can see the details. Typically, an operator at this stage is going to acknowledge the alarm and exit the details screen there. And you'll see now that the alarm status button has changed from red to yellow, which indicates that we have an acknowledged alarm condition. Now, if we take a look at the history, we can see both when the alarm occurred and when it was acknowledged. The history records when things occur, not strictly what's happening currently. Okay, now let's go back to the alarm status. Let's go ahead and trigger a new alarm. Let's say somebody presses the e-stop. Once again, the button is red. But let's say that the operator who triggered the e-stop is not going to acknowledge the alarm because they're busy making adjustments to the machine that tripped the e-stop alarm. Let's take a look at what's going on with the history. If we take a look at what's going on in the history, we can see that the e-stop has indeed tripped. And then, when the operator is done with adjusting the machine, they go ahead and restore the e-stop to normal. So we have a return to normal situation occurring. Now, if we go back and take a look at the status, if the operator is the one who caused the stop and didn't acknowledge it, and then they cleared the stop again, from a current alarm standpoint, they will never see it. However, going back into the history, we can see that it did occur. So that was a quick look at the alarm button and alarm window and how they work during runtime. Let's take a look at some future enhancements that we have in store for alarm handling. We are implementing dynamic alarm messages with embedded data. In the demonstration, I typed in fixed alarm messages without any variability to them. In the future, you'll have the ability to have dynamic alarm messages that can have embedded data with numerous data fields. For remotely acknowledging and clearing alarm conditions, you currently have one set of bits for acknowledge and clear. In the future, you'll be able to have one bit per alarm. We're implementing multiple severity levels, so that when you configure an alarm, you can also configure its severity, and then indicate that to the operator. We are also implementing the ability to configure level-based alarms, so you will be able to have alarms that are triggered like the current ones are, or selectively, you can have other alarms that are strictly level-based. For example, high-level alarms or low-level alarms. Thank you for watching today's tutorial. The Q&A session will begin shortly.
Hey everyone, so that was our graphical alarm handler explained and demoed. There aren't many questions in this morning, one or two here. There's an alarm handler function block available in the project toolbox. What is its function? Okay, that function block is actually for legacy controllers. That was implemented back in the day where we had OCS 100s and mini OCSs and OCS 200s text-based controllers. It's not to be used with current graphical controllers, and certainly don't use it in conjunction with the graphical alarm handler that we've just gone through. So again, they're just for legacy text-based controllers. So there's no requirement to use that alarm handler function block. I think we have a feature request and to grey that out for current products. Should alarm history be retained through a power cycle? Yes, it should. However, we did have a recent issue with the firmware version where it wasn't retained through a power cycle. Now, we have just released firmware. It's live on the website right now, version 1552, where we have corrected that. So alarm history is retained through power cycle. 1552 available now. Have a look at the release notes for items related to the version. Okay. Are there any improvements to how alarms are handled in WebMI? It's an ongoing process. I do know that we did introduce some improvements with 1530 firmware, I'm going to say, where the alarms weren't being refreshed properly, but we've corrected some of that now in the current firmware and software. Can you acknowledge alarms also via WebMI? Yes, I believe you can. That function is there now also. Anything else here, lads? Do we have any system registers for alarm handling? Yes, we have two. SR181 and SR182, both for they're bit mapped for the 16 groups. So SR181 is the alarms unacknowledged per group. So you'll only see a bit set if there's an unacknowledged alarm within a specific group. So if group 2 has an unacknowledged alarm, bit 2 of that SR181 will be on. And similarly for SR182, that's for alarms active. So they can be used in the logic as read only if you need to. Okay, I don't see any other questions here, guys. No, nothing else. So that's it. That's our alarms. I see a lot of you are registered for next Thursday's webinar on high-speed data logging. So that's another question coming in here. No, I'm sorry. So high-speed data logging on Thursday. Again, another short one, certainly less than half an hour. So we hope to see you all then. And until then, have a good day.